Okay, welcome to day 4 of our training. Till now, day 1, we looked at a very basic level of coding where we were just seeing how to work with get a program going with arrays and maps and slices. Day 2, we got the program in more detail. Day 3, we've looked at trying to get some random words in, looking at different packages. There were a lot of discussions around, and we discussed what about object-oriented programming in Go. So we did look at access specifiers of how to define structs, how structs are how we read them from the left to the right, what are exported, unexported names, embedding structs, resolving ambiguity, function receivers, functions like an object-oriented kind of method where we can call a method on a particular struct. We looked at passing by reference, passing by value. We played a little bit of tricks to understand what works. Then we got into a lot of discussions about how maps are passed, how arrays are passed. I hope everyone is getting back into the groove of understanding what we're doing because we had a 1 day break. We looked at methods returning multiple return types, and then we finally got the program going. Okay, now we are going to get into till now all these concepts were there in every other language. This time round, however, we are going to get into the nuances of Go which are different. Okay, so the first and foremost we are going to look at is the power of Go. The power of Go comes along with a lot of concurrency and parallelism. You may have heard of it, that Go is fast and Go can work on various different machines at blazing speeds and stuff like that. This is the reason. Now, even before we get going into the nuances of what is concurrency and what Go does, I want to ensure that we are all on the same page when it comes to understanding what is concurrency and what is parallelism. Okay, very often it is confused that it's the same thing. Can somebody give me an example of concurrency? A very, very practical live example involving things which are easily understood, that what we ourselves do in real life. Can you tell me what is concurrency? Unmute and answer, please.
Hey Gautam, I can answer.
Of course you can.
Yes, we eat during watching TV.
Perfect. You're eating while watching TV. You're doing no. You're doing concurrent things. See, that's what I'm saying. If there is always a confusion, very, very slight difference between parallelism and concurrency. Okay. The screen that you're seeing right now, is it concurrent or parallel? Watch, there are multiple windows. There is screen sharing. I'm moving the mouse. I'm pressing the keyboard. Is this concurrent or parallel?
It is parallelism.
It is concurrent. There are concurrent tasks happening. Okay. So whenever things are happening, multiple things are happening, it's called concurrent things are happening. When multiple things are happening at the same time, at the same instant of time, it is parallelism.
It is parallelism.
Okay. When we are doing multiple things
at the time,
concurrent. When we are doing multiple things at the same time, it is parallelism. Now, you can watch TV, but can I also read while watching TV? I can, but at one time I'll be doing one of the two. So I am doing concurrent tasks. I'm reading a book, I'm watching TV. But at one time my eyes are focusing, assuming our eyes are not really awesome. But assuming I can only watch TV and then I can switch. So these are concurrent tasks. But while eating, while watching TV, is my mouth is working, my eyes are working, my ears are working, my brain is functioning. All this at the same instant in time. That is parallelism. Okay?
But my intention was not there. I am just focusing that we are focusing at one time during eating. We are concentrated on eating, and during watching TV, we only concentrate on watching TV. Therefore,
here's the thing, right? Concentration is a very interesting word.
Yeah.
While you're watching TV, you're also listening.
Yeah.
So you're actually doing multiple things at the same time. You are also looking out. Your brain is, your brain is looking out for your mom or your dad who's coming early. Arey, enough for watching TV. Do something in life. You're still conscious of everything. So while you're doing multiple things, your brain is running in parallel, doing multiple things at the same time.
Yeah, sure.
Okay, this is the basic difference between concurrency and parallelism. Now let's get down to brass tacks and understand what it means to be concurrent in a computer program. The easiest way of understanding parallelism is multi-threading. Right? All of us have worked with multiple, are you all proud of having done multi-threaded programming? That's a trick question, by the way, because the amount of interviews that I have taken over so many years, every time, especially if it's a C interview, every time I say, let's talk about multi-threaded programming or inter-process communication. Let's talk about mutex and semaphores and condition variables and critical sections. What is your typical reaction? That silence. Let's keep quiet because now we are getting into the complicated zone which we are not really comfortable with. Am I right?
Yes.
Usually, multi-threaded programming has been considered extremely complex. And that is why the term nerds, geeks, all this evolved over the last 4 decades. Computer programming, once it became complicated because of all the multi-threaded programming, because of semaphores and mutex and all kinds of stuff. And Rob Pike, Robert Griesmer, and Ken Thompson, these guys, said that let's go back to basics. So they went back to the 1970s, literally back to the future kind of thing, and read about different things at one time. And they came up with this different way of approaching uh, concurrency and parallelism. And this was called communicating sequential processes, CSP. CSP is called communicating sequential processes, which was a white paper written in 1978. Believe it or not, people had, so when C was getting built, this paper was out there in 1978, and there was a paper on communicating sequential processes, and there was on pure multiple threads. At that, in 1978, people did not envision very clearly about the power of multiple cores. They were still working with the 8080s and the 8084 microprocessors, which were smaller ones. They did not expect microprocessors to become smaller than the size of your nail. At that time, they said this communicating sequential process is probably never going to be used, so they chunked the paper and went ahead with working with threading and critical sections and mutexes and semaphores and stuff like this. A different way approach for inter-process communication. Had they chosen CSP at that time, all of us would never have been geeky programmers. We would have probably just programming would have become just literally my grandmother could code. But let's not believe everything that we just hear or somebody says. Let's actually go and look into the details of this. When we talk about communication, when we talk about multiple threads, we are always trying to have some sort of memory being shared with each other. That is why you had a mutex. Mutex stands for mutual exclusion, which is like a lock. Now, it is going to be very difficult for me to explain on a call, but I'll try my level best. Now, picture this in your mind. Okay? You have a piggy bank, all this cute piggy bank with a lot of coins in it, sitting on top of the table. Right? We are 5 people standing around the table, equidistant from that piggy box, piggy bank. Now, the piggy bank has a lock and a key. Right? Please interrupt me anytime if you get confused with this confusion. So far, so good. Picture yourself, one among 5 people standing around a table with a piggy bank in the middle, which has a lock, and there's a key which is lying on the table. What are we going to do? All of us want the money. All of us cannot directly go to the piggy bank because it is locked. So you're going to rush towards the key. 5 people running towards that key is called a race condition. Somebody wins, somebody loses, but only one person will be able to pick up the key. Right? The person who picks up the key will go and open the piggy bank, take out some money, put some money, hopefully, unlock it, lock it, put the key back on the table. Now, while somebody else has the key and is working with the piggy bank, what are the other four people going to do? You're going to keep going to the table and saying, is the key there? Is the key there? Is the key there? Moment you see the key there, rush for it. Again, one person wins. This is typical, the supposedly easy way of communicating with each other. Okay. Now, what we have done is a shared resource called the key. That key is going to be picked up and it is going to lock and unlock that piggy bank. This causes a lot of races, starvation, and complexity. How about, to get the key, you may have to probably write something in a ledger. What if somebody takes the key, unlocks it, forgets to lock it, lock the piggy bank and puts the key back? Piggy bank is open for everyone. So all of you all are probably aware and have suffered some time or the other while doing multi-thread programming, that your program just hangs because somebody unlocked but forgot to lock, or locked and forgot to unlock, or locked a resource and again locked some other resource and caused lot of race conditions each other or deadlocks. So far so good. Any questions? I'm guessing there won't be any questions right now.
Understood.
Right now, this is how the chaotic nature of inter-process or intra-process communication with threads happens. Now let's change the game. Let's work with the same piggy bank, the same key, the same everything. Change the scenario. This is how Go works. There is a table which has a piggy bank in the center, right? That piggy bank maybe has a lock and the key is on the table. But somebody has kept the key there for the first time. That means somebody creates the key. Say I am one of the 5 people who creates that key. I don't keep the key on the table. I create the key, and because I am the person, the main thread who has created the key, that object, that key is with me right now. Because it's with me right now, I can go open the piggy bank, add money to it, and now I'm done with it. When I'm done with it, unlike other IPC where I go and leave the key on the table, I don't. I hold the key out with my right hand, and I am blocked. That means I'm blocked. I'm not doing anything until somebody else takes that key from me. So I hold my hand out. 4 people are racing not towards the table, but racing towards taking the key from my hand. Only one person will be able to hold the other end of the key. When that person is held, any one of the 4 is trying to hold that key, one person will be able to hold the key. The moment for me releasing the key with my right hand and the other person taking the key is an atomic operation. That means it happens in one clock cycle instantaneously. Now that key completely belongs to that other person on the table, and I just among the other 4. Now that person has the key. That person can work with the piggy bank, add money, remove money. When that work is done, you hold the key out for somebody else to take it. No confusion, no issues. Any questions so far on this? Because if you all don't have a question on this one right now, I do. Does something sound additionally complicated, or does it just seem the same as earlier? My question to you all is, do I really need the key? Do I need the lock on the piggy bank? So you got the scenario. It doesn't seem very different from the earlier one because everyone is still racing for the key. But now think of this awesome scenario. The piggy bank, I'm the main thread. I create the piggy bank. I don't have a lock. I don't have a key. The piggy bank is with me. right? I add money, I remove money, whatever I want to do the piggy bank, and I hold the piggy bank out for somebody else to use. Now, among the other four, whoever races to get the piggy bank takes the piggy bank from me in an atomic operation. That means only one out of the other four people at the table has the piggy bank. You can add money, remove money, do whatever you want, but that piggy bank is yours. Nobody is touching it, nobody is accessing it, nobody is doing anything with it. Then you hold the piggy bank out again when you're done. Somebody else takes it. Has this greatly simplified inter or intra process communication between all? Now I want your thoughts. Do you think this is just easy?
Well, it sounds like you wouldn't have any way to control, at least given the example you gave, which of those other people gets it first. So if you're waiting on an operation to be done of some kind, maybe you put money in the bank before trying to take it out, you could wind up with trying to take money out of the bank that has no money in it.
Correct. Example. Right. So there are very easy ways to handle this situation. Let's take this piggy bank situation, and I like the example of piggy bank. I'm evolving the piggy bank right now as we speak. Right. The piggy bank, okay, has a contract on it that everyone either has to put money in or remove money in, and if you don't have money, okay, if you don't have money to put in, then you can't remove money. All these constraints are just logical flows that we can put on the piggy bank object, struct, or method. Right? What is important in this particular case is that the piggy bank is being moved around there is still a race condition. There is still, the piggy bank is being held out in the middle of the table and four people are racing towards it. But instead of us trying to communicate by sharing a shared memory of a piggy bank, we are owning this memory and we are communicating, okay, with each other by sharing that resource, by passing it on to each other. Okay, so you are communicating with each other by pushing that piggy bank in the middle and letting somebody else own it. So this removes the entire complexity of having locks and critical sections and locking unlocking methods. Now, since piggy bank itself is a struct, you can put any kind of logic on it, any kind of method on it. Say, for example, I want to ensure that I'll take another good example here. A relay race. I am holding the baton out among the four people. Everyone has numbered 1, 2, 3, and 4. The baton is currently on number 1. If number 3 picks it up, he realizes, hey, it's not my chance. Holds the baton out till number 1 picks it up. The point is, the race condition will still be there, but you are now no longer trying to use these locking mechanisms. You are creating a resource and sharing that resource. Okay, which is called this concept of do not communicate by sharing, but share by communicating. Now, all this may seem complex, but we'll see an example shortly which will clarify everything for us. Okay? To do these things, first you need to have these multiple processes. By the way, sir, I'll hold here. Any questions so far? Did you understand the analogy of the piggy bank, the lock and the key?
Gautam?
Yeah.
I have a question.
Sure.
So when the piggy bank was on the table, the 5 people, they knew that when I want the money, I should go to the table.
Correct.
But now, aren't we adding an extra communication here? I don't know who holds the piggy bank now.
Correct. Yes. So the process of holding that piggy bank is called a channel. This stuff, the last point, is the channel. The channel, as the name suggests, is like a pathway. That channel can be of a piggy bank channel, can be of a boolean, integer, struct, whatever you want.
So it's like a broadcasting a message that I am holding the piggy bank?
No. Do not confuse this with broadcasting networking protocols.
Okay.
It is a construct. It is a native construct called a channel. The channel will only contain a piggy bank object. And that piggy bank object can be transferred from one GoRoutine to another GoRoutine. Consider GoRoutine for now as just other threads. It can move from one GoRoutine to other routine only through channels.
Okay.
So you are passing it. So it's a channel. On that channel, if I keep it, one other GoRoutine gets it. You can send and receive from a channel, but the send and receive is always atomic. This is how GoRoutines communicate with each other using channels.
Okay.
So
one
GoRoutines
GoRoutine doesn't have to know who holds it right now, like that.
No, you don't need to know who holds it. Yeah, if you want to read from the channel, correct.
Yeah.
If I want to read from the channel, I will just say I want to read from the channel. Till the moment somebody writes on channel, if there are multiple people, one of them will win. I still keep reading on the channel. When I actually win, I will read that entire contents of the channel. They will be with me forever, guaranteed that nobody is manipulated. Also accessing it at the same time, nothing of the sort. It's with me.
Okay.
So literally think about it. You're holding the piggy bank in two hands and giving it out. Moment somebody takes it, nobody else has access to the piggy bank. When you are done, you send to the channel. When you want to receive, you hold their hand out, like begging, I'm looking for it. There are 10 people holding their hand out. It will go to only one of the hands. They will give out, they'll send and receive from the channel. Okay. Now it may sound a little complicated. Before we get into the actual code, let's ensure that we have covered all the patterns of GoRoutines. Again, you go to GoTour, you will find this entire section on concurrency, right? This concurrency will talk to you about GoRoutines, channels, buffer channel, range, close, select. Today, we will look at a few GoRoutines, channels, and select also. Automatically, you'll understand. We've already looked at what range is. So let's have a quick look at what GoRoutines are. To create a GoRoutine is as simple as this part. You have say, which is a method, and just run it twice. You prepend go, it will automatically create a GoRoutine. You don't have to do any fancy stuff. Let me run it. Okay, you will notice that it is printing world and hello. Somebody's printing world, somebody's printing hello intermittently. This is actually running in parallel. What do I mean actually running in parallel? Suppose my laptop has multiple cores. Suppose it has 4 cores, there are 4 GoRoutines running. Chances are that all the 4 GoRoutines will be running on each of the cores. That is why people say that if your GoRoutine is idempotent and it is completely independent, there are 2 different words. Independent means there is no dependency on anything else, and idempotent means in any order you run, it will give you the same result. If these GoRoutines are written in such a way, like this, say, I will print something every 100 milliseconds, print the word 100 milliseconds after every 5 seconds, 5 times. It will always give you the same result, and it is not dependent on anything else. If when I run this code and there are 2 cores available, there is the main thread, which is also a routine, and that GoRoutine, they will run on different cores and execute the code. So it is very highly likely that if you have a program written in Go, which is running on a dual core machine, may run twice as fast on a quad core, may run 6 times as fast on a hexa core, may run 8 times fast on an octa core. I have actually demonstrated such a program to show you that it can run. Do you all want to see I have a screencast. Do you want to see one? This is what I'm going to do in the program. There are 4 GoRoutines doing their own tasks, but they finish in a particular order. Okay. The idea is the 4 GoRoutines will keep running, doing their own thing. But if 3 finishes before 2, it will keep waiting until its order until it finishes. This is the code. You can see the code there that I'm running. There's a run leg which is just doing a lot of massive CPU number crunching. Okay. I am running these in different GoRoutines, and you can run this code. You can see that it is running with S4 right now. And I will show you the CPU usage at 95%. You can see the CPU is running at 95%. I've intentionally said, do not use the maximum cores, use only 1 core. This is running at 95%. You will notice that it is taking some time. The leg 1, 2, 3, and 4 are churning. But even if one of the legs finishes before the other, like leg 2 has finished, but it will wait to exit until one finishes, then 2, 3, 4. Simple. All I do in this program is allow it to use 4 processors, maximum processors. Instead of 2, use 4 processors. And I run the same program. You'll first change you notice is that the legs have, the churning is, the order is different. The second thing you'll notice is that the CPU churn on this program has suddenly gone up to 300%. I have not changed a single line of the code, but it's churning at 300%. Visibly, you will be able to notice that this code runs faster and finishes faster. In fact, I think the code is already finished. You could even make out that it ran faster than the earlier one. This is an example of how code actually runs faster as the hardware becomes better. Any questions so far? That's a live demo, by the way. Screen share that I have kept long back. This is it is literally 5-year-old code that I was running. It still runs faster. Okay. Any questions so far? All right.
No question.
Okay, let's quickly get through GoRoutines. The reason this time I am going through the GoRoutines part is so that you don't miss out on anything. Very quickly, you have written any function, you can just prepend prefix go behind it, it will run in a GoRoutine. You do not have to do anything specific on it. This is a channel. You will always use the channel using make. We've used make before. Everyone remembers make, I hope. Make is used for either making a slice, a map, or a channel. In this particular case, I'm making a channel of an integer. That means on that channel, I can read. Please see where I'm highlighting on the left side of the screen. I can send to the channel. If ch is the name of the channel, to send to the channel, the direction of the arrow is as simple as that. And when I want to read from the channel, I'm reading from the channel. All I have done is sending to the channel and receiving from the channel. This is the operator which is being used to send and receive from the channel. So far, so good. Any questions? Okay. Continuing. Just like you have a channel, coming back to this, when channel of int, I can only send one integer at a time. That means if I'm going to send on the channel, that thread or that GoRoutine is blocked until somebody else reads from it. If I use a buffered channel of 100, it will keep sending to the channel and continue programming and it's continue its own code until their buffer gets filled up by 100. After that, it will block. Right? If you want to keep reading from a channel, you can use range. Range is a blocking call. That means this particular code on the right that I've highlighted, this for loop will block until something is available on this channel C to be read. And don't worry if you think I'm going too fast, we will actually be writing code today. Today, we might not want to get into a breakout room. We'll all do this together on my laptop so that we are all in sync with channels and GoRoutines, because this is a critical part and I don't want anyone to miss out on anything. Select is another way. Select is for non-blocking reads. We'll be using select today. If I want to read from multiple channels, this is what I do. And then we have a timer, ticker, this is exercise, blah, 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 blah. Oh, we sorted. Okay, keep this handy with you all right now so that you all can keep referring to it in case while coding you realize that there's some concept which is not clear. If I'm in the middle of something and you want to just refresh something, keep go to it. It will really help you out with this. Okay. Do I have anything else here? How's that for a presentation? One slide. This was yesterday, one slide today. And now let's add a timer in Hangman program. Adding a timer in a Hangman program will enable us to look at GoRoutines and the channels together. So you will get a very clear idea about how things work. and you will end up doing it yourselves. So it might be easier. So off we get to some code. This is my Hangman code. I'm just going to run y'all through this carefully so that we know that everyone's on the same page. There is a function called get keys. There is a get word. There are a few of y'all. I hope everyone's been able to do a get word. If not, I will share at the end of the session. I will share a gist which will get you this information too, or I'll just share this particular file too. The main entry is our standard stuff that we had put out. Okay, anyone sees anything? This should be the same code that you have written earlier. Since you all never got down to working on flag, let's actually go with flags first. Okay. Should I make a copy of this file so that you all can work with this later on? Or should I? Anuj, what do you think? Or should I just do it and send the final file?
I think final file is fine.
Okay. So I'm using the flag package. Flag package. This is a flag for command line parsing. Okay. You should read this up. It will help you all a lot. I will make it slightly faster. Flag.bool dev default value false dev mode. So far so good. I have created a boolean flag which means minus dev flag. I will go to main. You have to do flag.parse so that it will parse all the flags. And remember that I have defined a global variable dev. Okay, I need that in Word. If star dev return elephant. That's it. I'll recap. Flag helps me get command line arguments. I've created a boolean flag, which means if I just say minus dev, if I specify minus dev, it will automatically become true. If I don't specify dev, or I say dev equal to false or true, it will automatically become false. In default mode, I don't want it to be in dev mode, so it will go to this part. Otherwise, it will come in. Remember, flag.parse is the one which needs to be done at the start of your main. Otherwise, it will not parse. Let's quickly check this out. Go build. Hangman minus dev equal to true will always give me elephant. Okay, I'll try the other one. You can see that it has gone somewhere else. I have no patience in trying to figure out what this word is. Okay. Also, if I just say minus dev, it will probably run in dev mode. Okay, because it's specified. And it was a boolean, so it will automatically get set to true. Any questions so far? All good so far? Okay. So this was quickly, you've now got your random word going, you've got flags working. Now we want to add a timer. Okay? Timer. Let's go. Okay. Let's understand different things between a timer and tickers. I'm going to go to the start of this and just look at some of the things that are there. Duration. Okay. Duration represents elapsed time between two instances. A duration is something like time.now. Duration is basically how much time do I want to run in. Then you have time zone. You have a month, you have a parser, you have a ticker. Ticker is typically used when you want to have repetitive actions. Say every 5 seconds, send a heartbeat. Use a ticker. Every 5 seconds, it will get you something on a channel. I'll explain that later while we see the code. And it will get you that ticker. Time is used for working all different times of time. You can add to some particular timestamp. You can get a date equal. Is very interesting method. You have a timer. Timer is typically used for like a stopwatch or a stop or time countdown timer. This is the timer that we are going to use right now. What does the timer look like? Basically, the only exported field is C, and it is going to create a channel on time. So it is going to send me something on time. Okay. This means that on time.c, I'm going to get information about time, a channel. It's going to return me a channel. And it is easier if I just show it in the code. Please stop me if it starts getting a little complicated. I'll explain the concept again. T to time.timer. Is 2 minutes enough to play a game of Hangman? But for now, I will put it as maybe 5 seconds for testing. Okay. You have time.minute, second. What else do we have here? Here you go. You have time.nanosecond, microsecond, millisecond, second, minute, and hour. Okay. So you can use any of these to define what is your duration. So far, so good. I have a timer. Now, timer T has an exported variable called C, which is a channel on which it's going to send me the time. Or basically, it's going to say this is the current time. It is counted down after 5 seconds. Okay. The moment I create this time, the timer is going to start. I don't have to say start or anything. The timer has already started. Okay. Now, what do I want to do? I want to write some code such that if I don't finish playing Hangman in 5 seconds, it needs to time out. So far, so good. Okay. So how do I go about this? Now, if I say T.C, this is sending something. So I want to read something from there. If I read, this particular code will block for here itself, because if I keep waiting on this one. Okay, can somebody tell me what this particular logic is when I'm trying to read from this particular channel? Quick reference on channel. Receive from channel. You see the same thing here? I'm going to keep waiting till somebody sends me something. So if I write this down here, it is going to time out immediately. There will be no program which works. It will keep waiting on that till it times out. Do you want to run it and see? I'm not using it. Okay, let me actually give that. So for those who are using Vim, you can install Vim.go. That will help you out. Line number 69. Sorry, I have to say there's a method called new timer, I think.
Yes, it's new timer.
I will show that to you also. New timer. This is the method. Creates a new timer which will return you the object, timer object. Now if I run Hangman, minus dev, it's going to wait for 5 seconds and then start the game. Okay, you see this starting? But this is what I don't want. I want to start the game and the timer in the background also. So far so good. Any questions? Did you understand what this timer was? It waited for 5 seconds.
Yes.
It waited for 5 seconds. Starting, this is the time it's given me and how much time it has waited from the timer. 5 seconds exactly. It waited 5 seconds before starting the game. But that's what I don't want to do. I want to do this in the background. I want to ensure that the timer is going to expire only when my game is not finished in that particular amount of time. So either I put the timer in another Go routine or I put my code in another Go routine. Let's see how complicated it will be to put our entire code in a Go routine. Now I'm intentionally putting our code in a Go routine so that it will be, understand certain other nuances of Go. This is my block of code. What had I told you earlier? How do I do a Go routine? I can prefix something with Go. Prefix the function name with Go. I want to do all this for part, which is an infinite loop inside a Go routine. So I prefix it with Go. Will this work? Almost. We have said that we need to prefix it inside prefix a function. So I will just define a function. And I need to call that function. For all the people who are familiar with JavaScript, this is things that you do for a living. Am I right? This is called an anonymous function, which I'm running in a Go routine. Interestingly, if I remove this will also work fine. This is a function which takes no parameters. Okay, and I'm defining the function here till here, and then I'm calling this. This last two parentheses that you're seeing is the invocation of the function. This is called just an anonymous function. Let me just put this and see if it works. Does this work as is? It should work because all I've done is just called a function. Let me just get rid of that line number 16. I haven't used the timer right now, so I'll just come back to it. Okay, one more thing things that you do. Newer construct that you use, nuances of Go. Did you understand the error here? It said that you have imported but not used time. I know I'm going to use time in some time. That sounded nice. I know that I'm going to use the time package in some time. So I can just use the underscore and say just ignore it. And this will work. You will understand these nuances as you start working. Don't worry about it. Steph. Does this code work? It still works fine. What is different from this particular method and what we did earlier? Nothing. Nothing is different. Suppose I put it in a Go routine. What happens now? Go routine means it's going to start running as a different thread. Still built, Ryan? What? Can somebody tell me what happened just now?
The thread that had the game in it started, but your main thread also
as a different
started and didn't have anything to do, and so it just finished.
Absolutely right.
because we started a go routine. The main had nothing to do, and there was nothing to stop the main from waiting, so it exited. We'll just see. Good. Hey, welcome, Kirk.
Okay.
So because
Yeah,
I
I
added
overslept,
all I
so I
did is
missed the first half.
yeah, I saw that. No worries. Welcome back. Okay, continuing the video. Function. So it created a new go routine for this, and the main thread has nothing else to do, so it exit. So the program immediately exit. You see what I'm saying? So far, so good. Everyone with me?
Yes.
All I have done is added a prefix go, and suddenly all this logic has gone into a separate go routine altogether. Okay? Now, here are few questions for you all. This is running as a different thread altogether. Correct? Chances is defined as a local variable here. But chances is being used inside this go routine here. Can you all see this? Chances is declared outside this go routine. This go routine is now running in entirely different context. It's a different thread, a different go routine away from main. How is chances accessible here? We do this in Ruby, in Python, all the time. As latest Java 8 has also supported this. What is this concept called?
Closure.
Absolutely. Closures. This is called closures because I am accessing a variable which is defined in the context out in the same context but in a different scope. This is why closures work. Now I will show you why sometimes an anonymous function helps and how to use it. Suppose I want to write clean code because this main method is becoming very big. If I take this entire logic and put it in a different function, should it work? I'll call it function play. I've called it function play and I've put it in the for loop there. And I'll come back here and I'll remove all this stuff. And just say go play. Will this work? Any takers? Will this work? I've just moved the code into a different method. Correct. You agree? I have not done anything. I've just moved that entire function into a different method. Play. Should it work?
No.
Why not?
It's local variable.
Correct. All those local variables which I had access to this method are suddenly lost. Correct? All of them are lost. If I want to make it happen, I will have to pass chances. What else? Placeholder, word, entries, word, everything. Correct? So I'm for now, I can pass it also. There's nothing wrong in not passing it. Instead of defining a separate function, I'm going to declare an anonymous function here, which takes all this. Because closures are supported, I'm going to call that function directly, and this will work fine. Have you all understood why in this particular case I have declared an anonymous function? So that I can make use of all these local variables, word, entries, placeholder, and chances. So far so good. Any questions? Did you understand? Can somebody tell me what this is? Why have I put these two parentheses here?
Calling that anonymous function.
Calling the anonymous function.
I have a question regarding this.
Sure.
So the chance variable is accessible inside the Go routine.
Yes.
So suppose there are 3 Go routines running at a time. So this chance variable can be changed by any one of them.
Yes.
So it will get ambiguous value inside it.
Absolutely right. You're absolutely right. Okay, that's why you have to be very careful with anonymous functions. But let's just take that example and solve it also. If chances is the variable which is going to be manipulated, I want other like entries, placeholder to continue, but chances, I want it to be very, very specific. I can pass it here and just pass chances. This will also work fine.
Okay, so in this case, it will create a copy of chances, and every routine will have its own copy of chances.
Yes, correct? Yes, absolutely right. Excellent question, Anil. That this is how and this happens very often. And this happens very often. Say, I'll give you examples. Suppose you're trying to import 1 million records from some particular Excel sheet. The context of the Excel file or the database is always the same. But you want, and you're making, say, suppose I have 1 million records from a CSV file to be imported. I spawn 500 Go routines. All these 500 Go routines are going to get, say, 500 rows each. So instead of trying to create different methods, I create an anonymous function. I create one for loop to iterate everything. Every 500, I create the anonymous function and pass this row index and column index as local variables to that particular Go routine. Makes a copy of it, continues inside. Everyone will get their own copy. There are practical use cases to that. I can leave this code like this also, it will work. So maybe let's just leave it. Okay, so we get an example of passing local variables as parameters in anonymous functions. Any more questions till now? Okay. Yes.
Yeah, I have one question. If that is a copy, the chances variable, it must be returned, right? The updated value?
No. I'm sending a copy. So remember, Go routines cannot return values. It's not like a function call. It's running a separate thread. A thread cannot return anything.
So if there is a second Go routine and I want to use the updated value, I can't.
Yes, you can. Use this. Pointer भेज उसका. Pointer भेजो. And then if you are sending the pointer, it's the same thing that is getting accessed.
Right.
Correct? So no problems there at all. So everything is doable.
Okay.
Fine. Good question again. So far so good. Has everyone understood why I have written an anonymous function here and prefixed it with Go and run a different Go routine? So far. So I have a question for all of you all. Suppose the question that Mayuri just asked, that suppose I want to pass the chances variable from one Go routine to the other Go routine. One of these ways is passing it a global, passing the pointer to it, but everyone will manipulate it. What is the other way of ensuring without compromising the security of the chances variable? How do I pass it around between Go routines?
Using
a channel.
Channels.
Absolutely, guys. Use the channel and you can do that. In fact, as we go, sorry, what is that again? Did somebody say tuples? No, I guess not. Okay, so yes, use channels to transfer data between Go routines. Continuing the video now. Good, but our problem has been that thing crashes, exits immediately. Not crashes, exits immediately. How do I prevent that? With a timer. So now I added this timer. I'll come out here, and here I can listen to the timer. So now I'm going to wait for 5 seconds, and it'll just work. What do you think? Enable that. Do not ignore it. 8 minutes. Let me just check this 9 number. I enabled the timer to 5 seconds. I've enabled the timer to 5 seconds. On that timer, I'm going to keep waiting for 5 seconds till this clicks. fmt.println. Timed out. Any takers of what will happen now?
Game will run for 5 seconds.
Absolutely right. Game will run for 5 seconds. See, it's working. L. But 5 seconds ho gaya, timed out. Is this what I want?
No.
Kind of. This is what I
timer
want.
show
That
करना है
5 seconds game should time out. No.
Yes.
So the issue here is that whether I like it or not, I'm going to wait for the timeout. So it's not about showing the timer. This is the game is getting played. There's a timer ticking, but I have to mandatory wait for the timeout. So what happens when there is 2 minutes timeout? Timer for 2 minutes and I finish the game in 10 seconds. I still have to wait for 2 minutes. You'll see that in the video coming up.
Correct?
And then show the time. Time as well, basically.
Yeah, so we can show the, yeah, agreed. We can show the time, but trying to show the time on a terminal is actually a pain because you have to keep updating it. So I don't want to even get there. But this is the thing. I actually guessed the word. Watch this. The program is not exit till the timeout happens. Okay. This is the other problem. Second problem. This you saw this problem right now, everyone. That even if I guess the word, my program is not. It's win. You won it. But it will keep waiting till I time out. I don't want this also. If I win, I should exit. Make sense? What's the other way? Even if I lose, it waits till it times out. Did you see the timeout just now? I used all my chances quickly. And the word was, it game over, but it timed out again. So what I want to do now is, have you all understood the problem here again?
Yes.
I don't want to always time out because my timeout in the real world is going to be 2 minutes. Now what do? I keep waiting for a 2-minute game every time. Where is that timer gone? Timer. So for those who did not understand what the earlier problem was, this is the problem. And my program is stuck for the next 2 minutes, even though my game is over. Right? This is what I don't want. Even if I'm running and I'm exhausting all my chances, I have lost the game. You're out of chances. Word was elephant. Game over. Try again. But my game is not over. I don't want the game to always end because of a timeout. I want the game to end. When either I time out, or I win, or I lose. Does that make sense for everyone? Yes. So how do I do that?
Channel set a flag.
You gotta find some way to have the main thread.
Channel.
Okay, I'm done.
Yes.
Excellent. I'll repeat what you're saying. We need to have a way to instruct the Go routine that it's timed out. or the go routine needs to inform the main thread that I have won or lost. Which means I'm now trying to communicate between two go routines, the main thread, main routine, and the go routine. Right? And how do I communicate between go routines? Using a channel. Okay? Using a channel. So what I will do instead here is, I will create a channel. I will create a channel here. Say result of the game. What kind of a channel should I create? I create a channel using make. Again, a quick check on your Go. How do I make a channel? Using make. What? And remember, this Chan is a keyword, okay? It has nothing to do with Jackie Chan. Chan. What channel should I make?
Boolean.
I can make a channel of anything, any object, any struct, any data type. So in this particular case, I'll make a channel of Boolean. True if I have one, right? False if I lose. Okay? Now I need to read or write from the channel. So since I am here in this Go routine, I have both main and this Go routine have access to this result channel. It is the same result. Mayuri, your question. It is the same channel which is accessible to both.
Yes.
Right? I could, if I want this channel to be sent across different Go routines to a different method, I can pass this result as a variable also. As a parameter to some method. Correct? To a different function, I can pass it as a parameter also. Now, suppose I win. What do I want to send on the channel? Oh, sorry, this is loss. I have lost here. If I have lost, what do I want to send on the channel? False. How do I send something to the channel saying it's false?
Write to channel.
Write to channel. This is my channel operator. I want to send. Arrow is always the direction of the data flow. I want to send false to what channel? Result. This is how I send information to the channel. Quick check again. Send to the channel. Okay. What do I want to do after I send from the channel? This break is going to break the for loop. Correct? If it breaks the for loop, it is automatically going to return. Right? So if I send false to the result, and either I can break from here or I can return. Either way. But it is going to exit this Go routine. Is everybody clear so far?
Yes.
Okay. If I win, what do I want to do?
True. Write true on the channel.
Write true on the channel. Is there any other places where I exit from my Go routine? Here. This break is going to break from where? From the... So here is my suggestion. Whenever you are trying to exit or you want to return, please return. Do not break. This return is going to return from this Go routine. That means this Go routine will exit. By trying to put a break here, if there is some other processing which happens, it will end up processing somebody later on, 1 month down the line, add some other logic for the loop and all that stuff. It will create a lot of issues. Just return. Okay? Return. Return. What about this continue? Is this correct? I want to continue the game here. There is no end result yet. This is also key, duplicate, continue, found, true, chances. So far so good. Is there any other place you see an exit from this program? Okay. Now I have come here. Now, how do I read from the channel? Result. Will this work?
No, assign to variable.
Yes.
Let's see if it works or not.
No. So this is waiting for the timer channel as well. We need to do.
So here is the.
So will this work?
No.
And what is the problem?
This will raise second problem. It won't time out.
Correct, because it will block on the result channel until I get a result from the game, irrespective of whether the program times out or not, because I'm not waiting on the timer. Well, good Bhagyashree.
Other concept that I had mentioned, which I will reiterate. When you are sending to the channel or when you are reading from the channel, it is a blocking call. Everyone knows what a blocking call is. That GoRoutine will block. In this particular case, until I get a result, it will block. So I'm never going to read from the timer channel. So even if it times out, I am stuck. Even if it times out, there will be no reader. So this process will never happen. Let me show you and tell you how this thing will work. I'm resetting it back to 5 seconds. Well, built. Remember, my program is supposed to time out in 5 seconds. Minus dev. And I'll keep waiting now. I'm waiting on the result. I'm not waiting on the timer. So my 5-second timeout has been completely wasted. You see the problem here?
Yes.
And only when this happens, it will say you win and it timed out. That timer is clicked out and you've come out of it. But this has defeated the purpose of my program. My timeout has my timer is completely wasted. What is my wish? My wish is that if there is a result on any of these channels, I want to process it. I want to read from 2 channels at the same time. But reading from a channel is a blocking call. So is there some way in Go where I can read from multiple channels at the same time? I'm not reading from multiple. I'm saying if there is data available on any of these channels, process it. But don't block. Basically, non-blocking reads on a channel or multiple channels. Do we have the support?
Using select.
Using select. Perfect. You will see this right ahead here. See this range. It is a range is a mentioned also. Range is a blocking channel somewhere.
Yes.
But select is a non-blocking case. Select blocks until one of its cases can run. So this is the logic that we need to use. Select, but note select is inside another infinite for loop. Okay? Because select is going to keep blocking only until data is received on one of the channels. Then it will come out. So I want to keep going in that channel for either my timeout or my result. This is exactly almost what we are going to do here.
So adding a little bit of clarity here, maybe a little bit of correction here. Select is not a non-blocking call. Select is a way to read from multiple channels at the same time, but select will block. Select will block until there is data on any one of the channels that it is trying to read from. There is a concept of non-blocking select altogether, which means that if there is no data currently available on any channel, don't block and continue processing. If you add a default case in the select, it becomes a completely non-blocking process. So you can do default processing, so it will never block. It will continuously be processing something. But if you use a non-blocking select, remember inside a infinite for loop, it is continuously going to process. So it's going to use your 100% CPU. So be careful when you use a non-blocking select. This is the right way of using a select when you're reading from multiple channels, and only in very rare cases do you want to use the default case in the select, which will make it completely non-blocking. Okay, continuing from where we left off on the video.
Then it will come out. So I want to keep going in that channel for either my timeout or my result. This is exactly almost what we are going to do here. So first I'm going to use select. This is my case statement. And this is my other case statement. Okay. Now I have written something to the result, true or false. That means I want to process the result also. Remember that I think Mayuri, it was you asking what if I want to return a value from the GoRoutine? You don't return a value from the GoRoutine, you return a value on the channel and you can read that result. Here. If R is true, that means you have 1. Correct? Else, loss. In this particular case, because I've already written my print statements there, upward, I don't actually need to even process the result. So maybe to start with, we'll just keep it clean. And remember, the for loop is important, infinite for loop. Okay. Do I want to do something here? I don't know. We'll figure it out later on. Now, are we good?
Yes.
Now let's just wait for a few seconds and see if it times out. I'm not doing anything. I've timed out. Too bad. Hello. My program is not exit. My GoRoutine is still working. Oh my God. What should I do?
Anyone? What is the problem here?
You are used for select. So you have to remove that for.
Correct. That is one way. What is the other way to do this?
Add a return.
Correct. And not a return, break. Or in this case, a return will also work. Yes. Good.
So as simple as break from here. Okay. Remember that if I don't break from that for loop, where will it go? Should this work?
Break or return?
This is the main return. So good question actually. I'll make one return and one break because I want to show you all something else also. Okay. You caught me there. Put a break and put a return. I'll keep waiting. Keep waiting here for some time. I've timed out and it's still continuing. So my timeout break has not worked. Why didn't this work? What did it break from? No, we all have worked with select before, people.
Working on the key statement.
Okay. Select.
It has broken from the, it broke from the select, but still continued. I'll show you one more thing. There is interesting stuff in Go. It returned, exit, so far so good, everything working fine. But just out of curiosity, I don't like this return from the main, which is not good. I don't want to do it because I want to print a bye-bye. What do I do now? Better still. Okay. This will never get printed now. What do I do?
Default.
Now, any ideas? Anusha, you said return, correct?
Use defer.
Use defer. Oh, that's pretty cool. That's a fantastic idea. Yes, you're right. You can use defer. Actually, I didn't notice that too. Yeah, you can use defer too. Good. What else?
Maybe go to or something like that.
Fantastic. What else? You all have given really good answers. I'm impressed. The video plays it. Video tells you these answers too. Fantastic. Good job, guys.
Double break.
How do you do a double break? I don't even know what that means. What is a double break?
As in one inside the select, and after then one is after once the select gets over, then a break statement. Oh, in that case, it wouldn't work. No, it wouldn't work.
It won't work because then I don't know. Because remember, select is only going to break on one. So should I not? Then again, you're stuck. That means you write another select call. So you're stuck completely here. I want this to be printed. What do I do?
In that case, we can set a flag. But,
setting a flag here. That I got a result. If I've got a result or a timeout, still complicated. You're right. You have to set a flag for result. That means you have to set a flag for every bloody channel that I write.
Yes.
So let me introduce you all to a new good concept.
You can write the infinite for loop in a function.
No, that's not going to solve again because still a for loop. I want to break from the for loop. So one of the methods you said is right, put a flag. But if you really want to exit from this for loop here, how about that? I'm intentionally doing this, okay? Again. Do you know what these are? Do you remember using this in C? Go to statements.
Yes, unconditional jump.
Unconditional jumps. Here is the cool part that in Go you support a go-to because we've been taught as part of C programming that go-to should not be used very regularly, or they should use it only rarely under exceptional cases because it is an unconditional jump. Here you can use go-to and put a proper label wherever you want to go. And it is absolutely legal because it is unambiguous.
So just to let you know, good. So I like the defer solution for the last statement, but this was more to show you how to use goto. Instead of this, there is also one more way. You can add that label, that end label that is written. Instead, keep a loop before the for loop and break the loop. So you can give after break, you can also give a label name. Okay.
Five seconds. Too bad. Timed out. Work again. This will work. In the case of a win, you win. Works? Like it? We have seen GoRoutines, we have seen channels, we've seen communication, reading, writing on the channels too. I'm open for questions for some time now, before I discuss next part. The communication between a channel, until somebody reads or writes on that channel, this particular line that I've highlighted. If I'm writing on a channel, I am blocked until somebody reads it. So I know that I have transferred that data to somebody else. While you're working, you'll realize that you'll start making a lot of use of these GoRoutines. Automatically, inbuilt, inherently, you will start using a lot of GoRoutines. It's a way of life when you're programming in Go, because you want it to work faster, you want it to process faster. So you will use a lot of GoRoutines. To use GoRoutines, you will realize some places you want to use channels for communication, for control. You will automatically start using channels and GoRoutines, and they are much easier to use. There is no, you realize that I haven't even used the word lock anywhere here. Now, having said this, you do have a wait group, you have mutex, all these kind of things in Go. Okay? But typically between GoRoutines channels, you're mostly sorted.
Yeah,
Gautam?
I've got a question. One of our, or rather, I should rephrase that. My play loop is inside of a function called play.
Okay.
Inside that function, result doesn't exist. So how would I communicate with the channel from inside that function?
Pass the result. Pass the channel as a parameter.
That's what I started doing. But what's the correct data type that I should put in there? Result channel, result
Chan bool.
Chan what?
Boolean in this particular case. See my screen. This is how I pass a parameter.
Oh, okay.
And it just works.
All right.
Result passing is the same way. Just create, this is the data type. Channel of Boolean in this case, Chan bool.
Okay. Thank you.
Okay. I'm undoing that change. Okay. Any other questions?
I think we had a question here.
Yeah, I was asking that can we use defer for loop? Like in the tour, it said only for the functions.
Yes, you can use it in a for loop. You can use defer for a for loop, but you will have to wrap it inside a function, because defer evaluates at the time of when it is declared, but executes at when before returning. So you cannot just have an open block. So defer will always take a function. So if you have a for loop, you have to wrap it around an anonymous function.
Okay, thank you.
Cool, good question. Any other questions so far? Okay, just continuing to the last bit of the video.
So this brings us to the end of our Go basic training. What is missing here is that we haven't discussed interfaces, and we actually haven't gone around playing with a lot of structs and export, import, all that stuff.
Gautam, one question.
Sure, go ahead.
Yeah, so in the code you have used a select with a for, right? Any specific reason for that? I think I'm missing something. Yeah.
Select with a for loop, no?
Yeah.
Take this part here.
Yes.
Yes. I mean, there is, if select is a statement which is only going to go waiting on one of the two channels. If there is data on one,
that's what we need, right?
Yes, but only once. You're actually right.
I mean, in this case, we want either the time to be stopped or the game to stop.
You are absolutely right. I'm going to read from the channel only once.
Yeah. So if we want to read it multiple times, then only we need a for.
Yeah, you're absolutely right, my man. So we are sorted here also like this.
I think one of you all had asked, Rohit or Santosh, somebody had mentioned this, right? Remove the for loop.
Yes.
Yes, and that is the correct way to do this in this particular case. Okay, because we want to read from the channels, either of the channels, only once.
Yes. I will revert this. So this works fine too, but I'm keeping the other code just for reference now. Did you all understand what Anuj said? Because we are never going to read from result and the timeout again. I don't need this infinite for loop. I'm going to read only once, but I'm keeping this only for reference. Good observation, Anuj. Good. I have pasted the chat for this entire Hangman game with the timer in GoPlay. Y'all can go pick it up from there. And interfaces is the only thing that I have not touched upon till now. I don't think it is of criticality to a level which is going to hamper anyone's coding in Go. But quickly going through this, we have looked at packages, variables, functions, control flows, structs, maps, slices. We have seen a lot of the methods, pointer receivers. The only thing missing is interfaces. And I don't want to start doing or completing interfaces just for the sake of completion of my training. I would rather look into it in detail, but Hangman is not a good example until we get into the testing part of Hangman, where we build interfaces for tests. That is the other part that I haven't touched upon. In fact, Anuj, I would want you to take on the testing module because you're way better at it than me. I suck at writing these automation tests. Okay, and we have looked at concurrency. So there is a way that we can even automatically test this code that we have written for Hangman. All right, see you. Bye bye. Bye bye, everyone.
So, tomorrow will be our last day for training, day 5, where we will look at interfaces and we will look at testing. Interestingly, over the weekend, I got some time to play around with how we can really utilize interfaces. Tomorrow, we are going to change the game a little bit. The game core engine and the logic will remain the same. However, we are going to play this in our browser. The same game, the same output that you saw on the terminal, we are now going to play on the terminal and also in the browser. At the same time, we will be able to play with 3 or 4 different instances in the browser. Any takers how we'll be doing that? I'll repeat what I said. We'll be playing the game not just on the terminal, we'll also be able to support playing the game in our browsers. We'll be using WebSockets and thereby also learn how to use interfaces for our Hangman program. Okay. With that, we'll also look into testing. So once you start building interfaces, you'll realize the value of how we can test this code, the value of interfaces. So we'll learn about it tomorrow. However, this will be a slightly longer session. So we will start at 5 p.m. India time tomorrow till 7 p.m. India time. Okay, so we will take exact 2 hours for the last session. In case we get delayed, we will have this session again on Wednesday to complete the last bit. So I will try and complete our session tomorrow. Worst case, we'll get on to Wednesday, but I'll try and see if we can finish it tomorrow. Fair enough? Any questions so far? I know today was a little heavy, but the video recording should come out and for good reference for you all. Snehal, I hope you will be able to complete your program now after understanding.
Actually, completed this parallel.
Fantastic. Good. Good. Any?
Sir,
Yeah, go ahead.
sir, in this select statement,
In the
select statement,
uh-huh.
the result will be written false.
In the select statement, the return will be false. What do you mean?
Result.
Okay. Again, on the screen.
Yes, sir.
Yeah, in the select statement, the result will be false. So what's your
So
question?
what? So the result is the true. Then execute the fmt.println, and then the result will be false.
Okay. I think I have also shown this here somewhere. Hold on one sec. I'm just going back a little bit. I will show you. I've seen this. We missed that part. Maybe. Give it a bit.
Somebody reads it. So I know that.
Should I go back? Okay. Actually, Yeah. So basically, this result that you're seeing, you can take in a variable too. Let me show this to you on Go Play. Okay. Just open one. I'll just share my screen so you will understand what I'm saying. Sorry, one sec. Okay. So suppose I have I create a channel. Okay, it's called say result of Boolean. Okay. Now I want to, and I create one more, say exit channel of int. I have a select. I have a case. R equal to reading from result. If R println win, else fmt println use.
I think there will be an error
What might it end?
because if will not take true or false. It will just take an integer.
If will not
Yes,
take true or
no
false.
error, no error.
Of course it will work.
Yes, it will take. It will take. I
Yeah,
said
it
the
will work.
opposite.
Yeah. So that will work. Where is this missing thing? Line number 24 or line number 16. Sorry, I forgot to put the bracket.
Lose.
Yeah. No, I forgot to put the bracket. So now this is the case. Okay. And now I will have a go routine here. And just say, actually, let me just make these two global. Okay, fine. This is. You understand this part? I'm creating an anonymous go routine again. Okay. And here I will. No, I will do this beforehand. Okay. Fine. Remember when you create your go routines, okay? It will get off in a. Okay, so now I want to write to what? Suppose I send two. You understood how this will work now? I didn't call it. This will be win. How is it passing? I'm passing true onto the channel and I'm processing the result. So this is how you actually process the result from the channel. I'm reading from the result channel into a variable. Okay, Rohit?
Sir.
Understood? If I make this false, this will be lose. Fine? Understood?
Yes. Sir.
Okay, good. Any other
Channel is communication.
Yes. Any other questions? Okay. So then we'll meet tomorrow at 5 p.m. India time, and it will be a 2-hour session. If by about 6:30 I realize that there is a sizable amount of knowledge still to be imparted, then I will break at 6:30 itself and in 1.5 hours, and we'll do it on Wednesday. Okay. If there is nothing else, then we can end the session now.